Hello and welcome back. My name is Corey, and I guess you're my rubber ducks for the evening. And this is the series of episodes where we are building a computing language, a programming language, a template language from scratch using nothing but a terminal window and Vim, modernish C++ where appropriate, and a few tools such as Bison Flex, Google Test, ICU, and yeah, that's it. It's a language that is 100% custom. We're creating it, that is. And so if we don't write it, it doesn't exist in the language. And we have been doing, the last episode was a huge undertaking. We added native bound functions, and a native bound function is a native meaning it's compiled from C++ into the source code that needs to run when you call the function. So it's a compiled function, and it is bound, meaning it is tied to some object. So in our language, if you have a string, now the only one that exists, if you have a string that is hello, and you say a is equal to hello, and then say a dot length, parentheses. Well, length is a function, but it is bound to the object a, and happens to be a string. So, yeah, that's what we created. So, what does this mean? Well, it was, how do I want to say this? It was a huge undertaking. Um, the video, I think, edited is over 3 hours long. And I fast forwarded in two places, and my computer crashed once in the middle of that recording. So it was long. Today, I'm hoping it won't be nearly that long. But what are we doing today? We are going to extend this idea and add support to the map. Not the map. Sorry, said the wrong word because I was thinking about something else. Sorry. To the array class. So we're going to be able to ask the array, how many items do you have? What's your length, that is? Or should we say size? I think size, or should we say length? I'll think about it. Um, like I said, I've said this before. I'm not following a script, obviously. I don't have anything pre-prepared. This is 100% live coding. I've said it before, nothing up my sleeves. I don't have anything hidden away. I have a few reference things, but trust me, we deviated from how I had written previous languages in the first episode. So, or second episode. The first episode, there wasn't any coding. So from the beginning, we've done it differently. So anyway, yeah, we make decisions, and sometimes we live to regret them and have to change them. But this is 100% live, so you see the entire process. You see all my mistakes, everything. Let's go to the terminal window. If I say git log, you see the last commit that was made was the end of episode 56. And then I normally say, if I say git status, there's a change. Well, did I show this at the end? I think I did, but I didn't commit it. What is it? Git diff. All that it is the to do. I took out things that were already done, and I added that we wanted to add code comments into our language. We don't have support for that yet. And potential tail call optimization, and I talked about that at the end of the last video. What does that mean? It's something technical, something that would go into our virtual machines execution, but I think it'd be pretty good. So, yeah, that's on the horizon. But for now, well, let's just add that. So git add, where is this? Include tang.hpp. Make sure it's staged to be committed. So git commit -m, and this is going to just be update to-do list. Sure. All right. So now on the right hand side, I'll go ahead and do my customary make clean and make test watch. And all this is doing is it's of course, so make clean removed everything that had been compiled, so there's nothing being left over and from a previous run, and we are what's the word do I want to say? Oh, sorry, I was looking at everything compiling. It's late for me. It's 11:30 at night when I'm just starting this recording. Anyway, so yeah, it's getting started, and that way we can do stuff on the left-hand side, and as it compiles on the right and runs all the tests, so we see that it's working. That's always a good thing. We can just start on the left-hand side, and we're going to edit. Let's start off with a test. There we go. And this is the test that we had. All of these were correct. I'm going to add one more test that I'm pretty sure is going to pass. We can make it fail and then to make sure it's passing. But all that I'm going to do is I'm going to say print hello world dot length. So the point is that I'm calling the hello world here. We can do this even better. Put an exclamation point. Let's not have it as a semicolon, so it will just return the value, and let's check the return value. So asterisk I don't remember the syntax for this. Get result. That's what it is. Get result, and it should be well, I'm going to say 11. I know it's going to be I hit a series of things. That's why I did that. Okay. A series of keystrokes that made that happen. I'm going to put 11, but I'm pretty sure it should be a 12. Bound function. I'm sorry. On object. That's the test. And yeah, it should be a 12. Yes. All right. So that's working. I don't think there's any more that I want to add to that. So just to make sure, yeah. Sure. It's a very terse description, but we can deal with that. Okay, so now we're back, and this is on the string, and let's undo that. I'm pasting it here, knowing that there we go. And instead of string, this is going to be array, and we're going to test append. So A is going to be 1, 2, 3, and we're going to print. Let's go for a.length. And we should get the value 3. And we're gonna, should it be length or should it be size? In C++, it's going to be length. In Python, I think it'd be size. JavaScript, don't even remember. The length of the array, the size of the array. I think length is maybe more natural, and since we're leaving it length. Yeah, and our test is failing. That's good. So, did I want to do this one yet? Well, okay. I know that I want this test to pass, but there's one other thing I want to do. And what it is last time we got to a place, and that's always been my goal for each episode. That's why sometimes they're long, sometimes they're shorter, is we want to get to a spot where the program still compiles and all tests are passing. And last episode, that took a lot of work. And we got it working. It was like, that's it, we're stopping. So now I want to kind of massage that form factor to make it make sense in a larger context. So let me, just so this doesn't mess up anything, I'm just commenting these out so that I can, let's see, what all do we need to change? We're going to need to look at the source for, is it Tang base? I believe it is, yes. Where are these functions defined? Where is the string function length defined? Thing's going to be there, Tang base. And actually, there's a fast way of finding out. cd source, get grep-in gt8 length. And right here, tangbase.cpp. Yep, that's where it is. Okay, that's what we're going to do. So all right, and we're going to need to edit the include for a computed expression, the include for computed expression string, and the source for computed expression string. Those are the ones I think we're going to need. All right, so here we are. Tang base is right here. And we've got this object methods, blah, blah, blah. All right, so what is object methods? Let's go back. Let's edit the, just so we can see it, the, not source, the include for Tang base. So we've got this idea of a native bound function that is described as a type, and that is going to be where did I describe native bound function? I thought it was here. Is it in macros? Hey, this is native bound function. Sorry about that. That's what I needed to. Yeah, I needed to know this. It's defined here. That will be executed as bound to an object. I want to add one, and let's just say this is going to be a collection or a vector of native bound function objects. No, it's not a vector, it's a map. Of method names to native bound function objects. There we go. And what are we going to call this? Using native bound function map. There. And that is going to be a standard map of standard string to native bound function. And I don't believe I need these in separate namespaces anymore. Yep, we need to pound include map and pound include string. All right, and so now tangbase.cpp, instead of this being a map of strings to this right here, native bound function map. There we go. So that cleans that up a little bit. And in fact, normally I've been doing a lot of big commits. I like doing smaller commits. So let's get status, get diff. So I'm going to grab the macro change and the change in Tang base. So get add include macro and source Tang base. And so I'm not including the commented out tests in test.cpp. Let's do our commit message is by adding named type. What is the name type? Named type. There, so you can see what I'm doing. Native bound function map. There. All right. Move myself back down because now we'll just go back to where's the make? There we go. All right. on the left-hand side, we're back here, and now what we did here, the object methods is, and we're building up this thing. I don't like that all of this is right here. It should be in the string class. So what we're going to do is, where's our computed expression string? .hpp, so it's 3. And I'm just going to add, am I including macros? .hpp. Before I go any further, will this compile? It does. Okay. That's always a relief. This is going to return native bound function map, and it's just going to be, we're going to call it get methods. That should work. But who didn't add comments? This, what does this do? Return the just because this is going to run the compile, we'll see that it passes. We'll do this as one small commit. Evidently on the wrong screen. There we go. Yep. So git add include computed expression string, git commit add missing documentation for computed expression string dot get value. Okay, simple enough. Back to this. Now, documentation. What does get methods do? It will return objects that serve as how about this? The member functions I'm going to put down a newer type. Return Okay, I think that'll work. And now we just need this get method thing. So where are we putting it? I guess at the end. Oh, and I want this to be a static. Yeah, because it shouldn't be implemented necessarily on the object itself. I mean, you shouldn't have to instantiate an object to get this. So that's okay. We'll fix that now. And what do we need in this? We've got to go back to Tang base. And we are going to... Let's just get all of this. And now time to play cleanup. So I don't need that line. I think I can do almost all of that line. I need this one. So yeah, it's going there. Okay, so what does this look like? So for each one of these, we're returning a map. First of all, will this compile? Yes, it's compiling. Okay. And so we're returning a map, and each entry is a pair that is the name of the method and the function to execute. Yeah, okay. So now, back in 1, instead of, just to prove this, I'm going to get rid of computed expression integer, and here, this is going to be get methods. Yeah. Okay, so what is this doing now? Or what is the big picture? Well, so this object methods is just building that. In fact, can we even do it this way? Object methods. Will it complain about that? No. Okay, so we can put it in the initializer list now. That's always good. So nothing's failing. That means it's still, okay. I think I like this approach better. On the right hand side, we've got these differences. Get diff. So we're adding the bound native function collection to string. We moved it there so that we don't have to clutter up our Tang base. We're still going to have to call it in Tang base for each type that we support. But we don't have to define every function in Tang base itself. We can have all the strings, their definitions, in computer expression string, which is where it should be. And then we've kind of cleaned up our constructor as it looks cleaner. Let's add these. So get add include computer expression string, source computer expression string, and source Tang base. Make sure we got it all. We did. What are we committing now? Refactor. How computed expression method registry is built. I think that's good. Small things. We're back to our tests. Now that we've done this, we can do the array one. So let's go back to test. I don't have that open anymore. Go to the bottom. We're opening this up. Yeah. Okay, it's failing. It should fail. And now we need to edit. Let's look at our list. Our include for computed expression array and our source for computed expression array. All right, so our string ones are 3 and 4, and our arrays are 8 and 9. Okay, so in 3 we've got that there. And now in our array, we're adding this. In 4, we've got it defined, and in 9, don't know why it was collapsing it, but that's all right. This is no longer computed expression string. This is computed expression array. And it's going to have a length, but instead, we're making sure that we are computed expression array. Then we're going to static cast ourself as array. Ooh, we need to get value. Well, instead of get value, it would probably be get contents. Dot size, because, yeah. right, so we need to get contents. And let's just steal the get value. Oh yeah, I'm here. Oh, but that's not... What's my type? Standard vector of garbage collected. Return as a reference. Should it be const? For right now, we're going to say const. Yeah, you can look at it, you just can't touch. How about that? Return the how about the contents of this object? That's probably better. All right, so instead of get value, we're going to say get contents. Now, what's it not like? Oh, vector bus, it can't be. That's fine. I'll make it not a const. Okay, so what I say, it looks like it should work. It should. There's one more thing we have to do to wire it up. But what have we done? We've written a function called getContents. We've written this native bound function map that is that when we call length, it says, you know, what I need to do. And it's going to say, well, am I a computed expression array? If I am, get my contents, get my size, get the size of those contents, and return that as a computed expression integer. Otherwise, return an error that is what should this error be? Because we need it in the string class as well. how about type mismatch for how about that? Type mismatch a bound function to target object. Is that good enough? You know what? I have a feeling that we're going to want to use that error a lot. Hold on to that thought. We're probably going to break that out and do that. But anyway, okay. Still not going to pass. Why? Because we haven't told our language how to get there. So, Tang base. Right now we've got string. We need computed expression array. And now we're going to copy this line, paste it. Let's see, array, and is going to be computed expression array. Get methods. See if this works. No whammy, no whammy, no whammy. It worked. Yes. That's good. That's very good. So now we've got this nice, concise syntax for adding object methods. And we're basically just dispatching it to the different object types and saying, hey, give me your information. And we're not having to overly complicate the logic here. I know I just exited on the left-hand side, and I normally don't like doing that, but I don't care. At this point, let's make some commits. So for the string, oh, sorry, string, no, array, I read the word string here and that threw me off. But no, computed expression array, we're adding these. And then in the .cpp, we've implemented them. We've done the definition, I suppose. And then in Tang base, we added that, and then we added our test. Yeah, that is good. Let's do this as array .length method. Easy enough. Okay. Now, I'd mentioned, I'd kind of alluded to, I kind of want a basic definition for a member function that the type doesn't match. So if I were to edit the source, not the source, the include for computed expression .hpp and the source for computed expression string and the source for computed expression array. My question is, I tried to use a const expr once. See, const exprs came about after I had learned C++. You say, Corey, they've been out for over a decade. Yeah, that was after I learned C++. And so, must be a literal type. So I don't think I can do this. Okay, I'll worry about this later. What the goal is I wanted to put a definition here in computed expression that all these are public. So this is just going to be provide a standard error message for a type mismatch of a bound native function to computed expression. So between a what do I call this? There we go. Yeah, native bound function. To a computed expression. Yeah, that's what I want. And this will be static, and it's not virtual. It's just going to be it's not really get, it's like make. Native bound mismatched error. What's it going to return? Is it going to return a garbage collected value or an error? I think it should return an error that can then become a garbage collected value. Nope. It needs to return a garbage collected value. Okay, that's just to get it going. Oh yeah. What's the return type? Garbage collected. There we go. And in my array, that's number 3. I'm going to put that in number 5. So that is my error. There we go. Type mismatch. And now oh, the keyword static should not be there. Doesn't need to be there. It's like, what on earth? Garbage collected. Can I call it native bound error? Native bound mismatch error. We're now going to call it type mismatch error. Hey, we're defining this as we go. We can call it whatever we want. Native bound type mismatch error and native bound type mismatch error. Long names are okay, especially if they help you understand what's going on and they only need to be called in specific instances. Oh, I'm calling garbage collected. Yeah, that's not gonna be right. It's not garbage collected. It is computed expression. And all the tests are still passing. Good. All right, so what does this mean for us? We can copy this and go to B2. And for our... There. So all of that did is now it's going to use that type mismatch. Error. So now we're going to have a consistent error message. Right now we actually don't have a way of causing this to happen because we would have to basically have malicious code that I don't yet even know how it could be executed. So there would have to be an exploit, and I'm obviously not intentionally going to include an exploit. In my language, that would not be smart. So, so we can't really test this yet. But let's go ahead and commit these. Get diff, that's what I meant to do. And yep. Provide a standard error message for computed expression methods for when there is a type mismatch. Method declared type and the actual sure. That's long. I know it is. I will apologize now, but it will work. Okay. Now, we want to do one other thing, and that is I want to append to an array. We haven't been able to do that this entire time. We can we add two arrays together? I don't know. But I just want to be able to call append. And that will show that a method can mutate the mutate the, and I just kind of stopped. It can mutate the object that it's being called on. So what are we going to do? We're going to say test because we need to write a test for it. And then we're going to edit the computed expression array. Yes. And then the source for computed expression array. I said append. That should be length. Test. This will be append. Okay. A dot append. How about that? And what am I expecting this to be? I'm expecting to be 1, 2, 3, and then the length is 3, and then 1, 2, 3, foo, followed by 4. Not a comma, just a 4. That's what I would expect to work. It's not going to happen. Yeah. Oh, I don't print out A in the first place. Well, let's fix that. There. Still would have been broken, even if I'd fixed it. There we go. Okay, so it is at least printing out the 1, 2, 3, 3, and yeah, it's just not doing the append yet. Oh, there should be a comma after that. There. All right, now, what are we going to need to do this? Well, right now, because we've got this get contents, but it is sorry, I know it just kind of trailed off because I was thinking. Get contents, and it will return the actual vector, but it's const. We can't modify it, and we shouldn't modify it, generally speaking. So let's write append an object to the contents. Of this array object. Okay, so param is going to be value item. To this array. And what is it going to return? The current object. Okay, and so what does that mean? We're going to return a garbage collected ampersand, because we're basically going to return ourself, and we're just going to have an append and we're going to need to pass in actually don't think I need to say Tang here, but I will. Item. Okay, that's in theory what we're going to need. Where did I put that? I put it right after get contents. Where's get contents? Oh, found it. All right, and now we just need to say this arrow contents push back item return. Ooh, nope. That's bad. I can't return this because this is not a garbage collected. In fact, you know what? Return. It's a void. There. So this is just a wrapper. And so therefore this should be void. There is no return. Okay, that should match up. Now we have to write the function to use it. So just like we had this here, we've got length. We're going to have append, and this is no longer going to be unused. If args.lengt size does not equal 1, return, we need another error. There, that's what we need. All right. Else, or auto ampersand item is equal to args at 0. And this will be okay, so now it's a computed expression array dot append item. It doesn't return anything. That's fine. Return, what is target? Garbage collected. Each one of these should return something. Yeah, it should. All right. Yeah. I know. Okay, so just for the moment. Okay, I'm just stopping here, and I know I deleted that, and I want to put it back, but our test is passing. And so I want to go ahead and commit this where we are. Where we have an append. We provided the append functionality. There's that there, and now we want to, we got our test for append. and it prints out A, then we append A, and then we, get its length. Yeah. There should be a native bound as opposed to just on the object itself. All right. Now I'm going to zero. There should only be 0. And we say we don't have a native bound account argument. Yes, I know that. So we need to edit our computed, our include for computed expression. What am I calling it? Native bound argument count. Native bound argument count. There. JK, didn't mean just kidding. It meant that's my navigation for up and down in Vim. Which one? Okay, I'm in for there. Native bound argument count error. For an unexpected argument that should work. And now we need to write this function, and we can do that in source computedexpression.cpp. There we go. At the end, there we go. So this should be error of arguments How about to method? I think method, because this is more of a user-facing error. To object method. And so this one should be of, instead of bound function, it should probably be object method to it's, should there be an apostrophe there? I don't remember. No, an apostrophe means it is. It's been a while. Let's make this error happen. So these are the class functions array, class functions string, and there we go. And this is going to be test class functions general. In fact, I think I'm going to do it this way. Dot length, and let's not do anything else, and then that way we can use the construct of this and get result. See if this makes sense. Okay, so it needs to be an error. Say I should know that. I forget. I do most of this late at night. I don't remember. Oh, why? Because I don't do the check in that one. So I need to edit the source. For computed expression, I know the reason I stopped and just stared for a moment is because I was thinking, I hate to have to include this manually for every single thing that we do, but we might have to come back to this and do it in the next video just because, well, this video is over an hour long. We've gotten a lot done in terms of cleanup and individual parts, but yeah, the more that we could do manually, the better off we would be, I think. And so I know it just stopped because, again, I'm thinking. Yeah, I'm gonna table that idea of figuring out a way to always to check this outside of the function. So that my idea is I want to, those two functions, those two errors that I'm providing, those to me should go outside of the function itself. Shouldn't have to check for that. It should be done, and it shouldn't even get to the function if it doesn't have the right number of arguments or if it's not the right type. So that's a problem for future query to solve. For right now, let's just get it working. And the problem is right now the string does not make this test. So we're going to edit the source computed expression string. See, right there. And let's grab the computed expression array. That's B3. be I know it just said B3, whatever. B6. I broke stuff. Oh, because I'm saying if it doesn't equal 1, it should equal 0. Okay, now I have unbroken stuff, which means fixed, but I've unbroken it. And this error message needs to be incorrect number of arguments provided to object method. That is right. I still don't like the way I'm testing for this error, but we'll get there. For now, I think that's where I want to kind of wrap up. So what all do we have in this one? We're now testing for, we know it works with the correct number of arguments, and we know that we're catching an incorrect number of arguments. We're having to do it manually, but the test is there and it's working, and the test for the correct type should be there and working. And yeah. And I mean, we did other things, like we have an array length and an array append. So that's good. In fact, we can do, well, I was going to say we can do one more test for array append, and I may write that really quickly, but first let's get this testing the array length. So get status, get diff. This is native bound argument count error. And we're checking that. Yeah. Add test to verify that the correct number of arguments is being supplied to a native bound function call. Okay. Last thing, I just want to add one more test, and it is testing append, but test the return value of append. And all I want to do is I just want to print a dot append. And that should print 4. That's what I'm expecting. Oh, no. I said 4. Because I was thinking of the next test. I said I was only going to write 1. I'm going to write 2. This one, that's correct. It should have printed out the 1, 2, 3, foo. And that is exactly what it did. And now, so there, I'm going to do one more. And this is going to be test chained methods. So a.append foo, and then whatever it returns, call length. And that should print out 4. And it should fail because I'm not passing in the right stuff. But yep. There we go. I am happy now. There we go. And now we've tested for chaining and a return that it's returning a value, because I think in all the ones before we just called it, we never checked for the return. So it should just be one file different. That is correct. Git commit, and it is going to be add test for bound function return value and chainability. I don't even know if that's a word. Is chainability a word? Should be, if it's not. So let's look at this. What all have we done tonight? There, updated our to-do list. We added a native bound function test on initialized objects. We simplified our code by adding this named type native bound function map. We added missing documentation for the get value function. We completely changed how the registry is built. We added a .length to the computed expression. We got a standard error message for the type mismatch. We added an append to the computed expression array. We added tests to verify that the correct number of arguments is being called, even though we want to kind of abstract that out a little further so that we don't have to call it explicitly. It just happens, and that will simplify all of the methods. And then we're testing the return value and the chainability of our functions and demonstrating that it works. Yes. Very happy. All right, so make docs PDF. My computer sounds like an airplane about to take off. Probably making more efficient use of cores than my compile does. Oh, a bunch of untracked files. That's all right. For episode, what episode number are we on? I know, I always forget. 57. Wow, that's a big number. For episode 57. Push it on up, and then we'll tag and push the tag. $57. I'm slow on typing numbers, you probably have noticed. And then one of the last things we do is we'll say Just verify that everything is still building. I should have done that before I committed and pushed, but oh well. 9,000 lines. We have passed that threshold, and we still have work to do. This is going to pass the 10,000 line, and that's code, lines of code. That's not lines of. I mean, that's not empty lines. How many of those do we have? 1,500. How many comments? Almost 3,000. Well, 2,800. Yeah, it's growing into a respectable project, and so much stuff left to do. Hey, all of our tests passed. That's good. And well, I have a lot of plans still. I have no idea how many total episodes this is going to be. I've had people ask me, Corey, how many are you going to do? I think they're really saying, Corey, we're worried about you. Please stop. Because I'm still trying to put out a video a day, so I still work my full-time job, still go to church, still hang out with friends, still all that other stuff, and still cook my meals, and sometimes record a 3-hour video or a 4-hour video in the case of the last one, and have to edit the video when I need to edit it and upload and all that other stuff. It's a lot of work, and so I've put in a lot of work on this series in the last 2 months, but I'm honestly very proud of where it is right now. My forearms don't like me. I should probably take a break to avoid, I don't know, carpal tunnel, whatever. I'm also a pianist, so I had to practice the piano. I still practice the piano almost every day as well. We're at the time of this recording, it's close to Christmas time, and quite frankly, Christmas music is hard, especially traditional Christmas music. And I mean, it uses a lot of times unfamiliar chord patterns, so yeah, it takes some practice to when you need to play. Silent Night is easy, by the way. Some of the others are. The first Noel has a lot of stuff in it, and I don't like the key of D. Sorry, that was completely off topic. Hey, from my perspective, it is 1 a.m., and I still have to maybe edit this a little bit, upload it, all that other stuff, so, oh well, I'm tired. Thanks again, though, for joining me, and as always, hey, I hope you're enjoying the journey, and I hope it's beneficial to you. Thank you. Have a great day. Bye.